It's me, Mario.
I am back. Sorry about that, guys.
It's me.
needed some better music. Alright, so I'm just going to restart the camera chapter. I probably should do more review as well, but I don't want to really jump into the camera chapter and kind of forget what I was doing, so. Alright, in the previous chapter we discussed the view matrix and how we can use the view matrix to move around the scene. We moved backwards a little. OpenGL by itself is not familiar with the concept of a camera, but we can try to simulate one by moving all the objects in the scene in the reverse direction by giving the illusion that we are moving. I think I need to actually, since I deleted something. Alright, so with camera, I have everything written down, but I want to do a review. In this chapter, we'll discuss how we set up a camera in OpenGL. We'll discuss the fly style camera that allows you to freely move around in a 3D space. We'll also discuss keyboard and mouse input to finish with a custom camera class. When we're talking about camera or view space, we're talking about the vertex coordinates as seen from the camera's perspective as the origin of the scene. The view matrix transforms all the world coordinates into view coordinates that are relative to the camera's position and direction. To define a camera, we need its position and world space, the direction it's looking at, a vector pointing to the right and a vector pointing upwards from the camera. A careful reader may notice that we're actually going to create a coordinate system with 3 perpendicular axes with the camera's position at the origin. Yeah, so we have a positive z, so we're moving our camera on the z-axis, and then we have our where it's looking, so it's pointed at the origin, and then we have our right, so it's kind of in between the z and the negative x-axis, and then we move it up 1 to give it a height, so it's not just pointing straight down at the like just pointing straight where we can't see the objects. Okay, camera position. Getting the camera position is easy. The camera position is a vector in world space that points to the camera's position. We set the camera at the same position we've set the camera in the previous chapter. Awesome. So let's go in here and remember that if we subtract two vectors from each other, we get a vector that's the difference of the two vectors. Subtracting the camera position vector from the scene's origin vector results in the direction vector we want. For this view's matrix coordinates, we want its z-axis to be positive, and because by convention in OpenGL the camera points towards the negative z-axis, we want to negate the direction vector. If we switch the subtraction order around, we now get a vector pointing towards the camera's positive z-axis. So it's pointing at the origin, and then we have the difference between, so our actual camera direction Alright, so now the name direction vector is not the best chosen name since it's actually pointing in the reverse direction of what it's targeting. Yo, how's it going, Vyomi? It's good to see you, man. I just figured I would do a quick stream. I don't know how long I'll stream for, maybe an hour or two. And get some stuff done. Hey, how's it going, Vera? I'm back, yes. I'm back for now. We'll see where I end up. I don't know. Congrats on new life. Thank you. I appreciate it, man. Yeah, I'm definitely gonna keep streaming for sure, but the next little bit's gonna be a little rough. Trying to figure out how to balance everything. Alright, so now we got our camera direction, which is basically what we're pointing at. So we have our origin, and now we need to do the right axis and then the up axis. So the right axis is, so we need to basically pivot the camera. Represents the positive x-axis of the camera space. Represents the positive x-axis of the camera space. How's it feel to be a dad? Good. It's like honestly the best thing in the world. I've been loving it so much. If you can't tell, I'm a little tired, obviously, but like, it's been amazing. Yeah, so this basically is just like our offset, so that we're not just staying on one of the axes, we're actually between the two of them, so it actually gives us a pivot in a sense. I don't know if pivot's the right word, but it's like, so we have our up is equal to another matrix C, or actually just a vector of 0, and then it's up 1, and then we have our actual right. And normalize is going to basically just do the same thing, but we take cross, and then we do up, and camera direction. Alright, sweet. Also, sorry if I pinged. I realized after I pinged everybody, and there's a lot more people in the server now, so I'll do better at like not pinging everybody and just ping the like the notifications rule. Okay, so since the result of a cross product is a vector perpendicular to both vectors, Okay. The result of a cross product is a vector perpendicular rule. And a cross product, let's look at that is. Or vector is a binary operation on two vectors in three-dimensional space that results in vector perpendicular to both original vectors. Gotcha. Okay. So we don't need to know too much about exactly what it's doing. Also, let me know how the music is. I kind of just have like... Let me... Yeah, this is good. Now that we have both the x-axis vector and the z-axis vector, retrieving the vector that points to the camera's positive y-axis is relatively easy. We take the cross product of the right and the camera and a direction vector. Okay, so up-axis, which points to the camera's positive y-axis. Okay, now we have our look at matrices. Our matrix. Let's see. Alright, so now our look at matrix is essentially going to take a great thing about matrices is that if you define a coordinate space using three perpendicular or nonlinear axes, you can create a matrix with those three axes plus a translation vector, and you can transform any vector to that coordinate space by multiplying it with this matrix. Yo, how's it going, Rose Polo? How's it going, man? It's good to see you. It's good to see everybody again. It's been like almost a week, I think. I'm just doing a quick stream today because I don't know what the rest of my schedule is this week, so I was like, might as well try and get a quick stream in. Don't want to get rusty with this stuff because it's really a lot of information. I'd say I'm doing pretty good at remembering what's happening for the most part. So our look at matrix is basically it basically takes all of our axes and translates them to when we're looking around, so that like if we're moving around, it takes everything and translates that. I think that makes sense. Yeah, R is the right vector, U is the up vector, and D is the direction vector. I wrote all this down as well. How's it been? It's been amazing, man. I mean, being a dad has been the coolest thing in the world. And I've gotten a lot of rest, which has been good, but also I've been up all night, you know. Typical newborn stuff. You can probably tell I'm a little tired, but like, I feel great. Using this look at matrix as our view matrix effectively transforms all the world coordinates to the view space we just defined. The look at matrix then does exactly what it says. It creates a view matrix that looks at a given target. Yeah. Okay, that makes sense. Congrats. Hey, I appreciate it. Yeah, so let's do our look at matrix. So I guess, oh yeah, we already have a look at built-in function. We have our X. Or no, this is our Z. And then this is our what we're looking at. So the origin. My bad, I have to go snooze now. Way too late, just saw you were live and had to pop on. Hey, I appreciate it, man. Thanks for being here. I hope to see you again soon. This will probably be my only stream this week. I don't know yet. We'll see. But thank you for popping in, and yeah, feel free to chat in the Discord. I mean, whenever you're available. I need to start talking in the Discord more often for sure. So this is our Y. Oh man, I really need to switch to Neovim, but it's tricky sometimes. I'll just leave it like that for now. So now we have our look at matrix. The lookat function requires a position target, and up vector respectively. This example creates a view matrix that is the same one as the one we created in the previous chapter. Before we delve into user input, let's get a little funky first by rotating the camera around our scene. We keep the target at the scene of 0, 0, 0 by using a little trigonometry to create X and Z coordinate each frame that represents a point on a circle, and we'll use these for our camera position. By calculating the X and Y coordinates over time, we are traversing all the points in a circle, and thus the camera rotates around the scene. We enlarge this circle by a predefined radius, and then create a new view matrix each frame using the GLFW's getTime function. Gotcha. So I guess we'll just call this. Okay, so we have our view matrix. And then we need to basically translate it around the radius that we have. So There we go. So now we got our camera rotating in a circle. This little snippet of code of the camera now circles around the scene over time. Feel free to experiment with the radius and position direction parameters to get a feel of how the lookat matrix works. Also check the source code if you're stuck. Okay, and then I'm guessing if we update our y-axis, it'll just put us up. Looks like it. Let's update this to like 50. Yeah, so we're like way above it. So drives me nuts that it indents it every time I paste. I need to fix that. So We can just kind of put these as like reference. Because we're not actually going to use these ones specifically. So we have our projection matrix. A view matrix is going to contain a camera. So we have our camera position. Oh yeah, I need to do my Pomodoro. Forgot. Let's see. Now we need to. Now we basically just gonna need to go to our input, our process input. So which we will set to a delta time after, because a delta time basically makes it so based on any processing or any processor this is running on, or GPU, it is consistent across machines. You were very helpful. Thanks for your info. Yeah, of course. I'm just curious, what's been helpful in this stream. Sorry, guys. I am like so tired from having a baby, or like obviously my wife. I'm just tired from being a dad. So, and then we set our camera position plus equals. So every frame or every time we press it, gosh dang. We update our speed and our position, so. About OpenGL. Yeah, of course, man. I appreciate you leaving that comment. I have been learning this for, I mean, OpenGL specifically about not 5 weeks, sorry. About 3 weeks, but I took a break. And it's been really good. I actually have learned a lot about not just OpenGL, but C++ as well. So let's see, what did I do wrong here? Window, G left W key, W. Hey, how's it going, Jake? How goes it? Dude, it's good. I'm exhausted. I'm tired from being a dad, but it's amazing. I'm having a good time. And I figured, you know, I have a little bit of time. I better do some review and kind of keep going with the learning. Otherwise, I will forget it. And that's another thing, too, guys, is like, once you start learning something, you got to go back and review it. Otherwise, it becomes kind of hard to review. How are mom and baby? They're great. Yeah, they're good. They're doing wonderful. Obviously, I'm not going to share too much about my family's life on here, other than, I mean, I'll tell you guys I'm a dad now, and it's been great. My life has definitely changed a lot in the last few days for everything good. Yeah, of course. Yeah, totally. And I'm not saying that in reference to you saying anything. I'm just saying, like, I probably won't. I just want to be careful in general about what information that I give out online. Which everybody should be, you know. Is OpenGL library work on Mac and Linux, or are there some differences? Yeah, they work on. I'm on Mac right now. Essentially, OpenGL is pretty consistent across. OpenGL is a library that works with C++, and depending on the compiler, I mean, on macOS, I think you have, what's the compiler on Mac? I think it's Clang. What is the C++ compiler on Mac? I think Clang, yeah. So I mean, as long as your compiler, OpenGL support on Mac is limited to 3.3 as I recall. Linux and Windows both support up to 4.6. Mac compiler is Apple's flavor of Clang. Yeah, that makes sense. Hey, good night, Vera. Have a good one. Thank you for joining the stream. Yeah, I mean, it's working. All I'm gonna say is, if you want to learn on Mac and you have a Mac, it'll work great. I mean, I've already made some programs with OpenGL and in classes before, and like what you can do with it is pretty great. But yeah, let me look. What version of OpenGL is supported on modern Mac books? Running are limited to OpenGL 4.1 regardless of the GPU's native capabilities. Apple deprecated OpenGL starting with macOS 10.14 and has ceased active development, meaning the API will only receive minor changes and no updates to newer standards like 4.5 or 4.6. While the official Apple implementation is capped at 4.1, several workarounds exist for developers needing newer features. Yeah, so I mean, I don't really need the newer features on my MacBook. I have a PC with Linux. All I'm gonna say is like, if you need the newer features, then use Linux probably. I don't suggest using Windows ever. I mean, most people wouldn't. It's, especially nowadays, it's really bad. It's just full of bloat, and it's taking AI in the direction that it does not need to go. I'm just wondering, why is this? Oh, camera position. Oh, I think this needs to be defined. Yeah. So let's... But I will say, like, I also think just Vulkan would be the best thing to learn after you learn OpenGL if you want to get into graphics programming, which I haven't learned Vulkan yet, but I know that it's probably more modern for the most part, which is probably going to be my next step after I make some projects with OpenGL. I just need to get, it'll probably take like 5 or 6 months to get stuff done with OpenGL before I move on to Vulkan. That's my goal, at least. If I can get some stuff made in OpenGL in like 6 months, I think I'd be happy to transition to Vulkan, depending on how I'm doing. Interesting. So even though we defined our variables inside of main, oh, they need to be global. Never mind. That's why you can't. They can't be in main. So if we just go up to the top and make them a constant, or make them a global. I mean, not a constant. Oh, it should work. Yeah, there we go. I'm honestly just going to copy this because I don't need to copy. Well, let's see. Let's just read it first, though. Gosh dang. Okay, so W makes us move our camera position and speed times the front, and then S which would make us go backwards should negate that, so we would do minus equals, and then A would go left, so we would want to go minus equals, and then we'd need to cross that, so we'd need to do a cross between those two between those two axes, which is our front and our up. And then that also is normalized, and then the same thing for right, or for D. So that makes sense. So I can just copy this, honestly. There we go. Now, assuming, yeah, there we go. Let's see. Once you know that much, learning Vulkan will mostly be learning Vulkan, not Vulkan and graphics programming concepts. And then once you've done that basic stuff in Vulkan, you'll probably be familiar enough with the basics to move on to more advanced graphics programming topics. Once you've done enough OpenGL to say, okay, I understand transforms, meshes, vertices, and the render pipeline, basic lighting, you're probably good to move to Vulkan. Yeah, I would say Vulkan is like a far goal, just because with OpenGL, there's so much you can do with that, and I think that in combination with like DRM GUI, which I'm pretty sure is very good for making a lot of different window, like, let's see, DRM GUI, Let's look at the wiki. Getting started. So I'm guessing Deer on GUI is more of like something I could probably make like games with if I really wanted to. Yeah. Which I'm not entirely sure. Okay, what is Deer on GUI? Because I'm sure I know it's not a graphics framework and graphical user interface library. Okay, so it's a UI library that you can use in combination with GLFW and OpenGL, I'm assuming. So it basically gives you all the tools to make Windows and UI. It outputs optimized vertex buffers that can be rendered in any 3D pipeline-enabled application. Supporting bindings for OpenGL, DirectX, Vulkan, and windowing systems like GLFW and SDL2. Gotcha. It is particularly suited for game engines, real-time 3D applications, and embedded systems. I'm definitely going to want to learn that then, because that's all the things that I want to learn is a UI library. Gotcha. Yeah, thank you, Jake. Appreciate the... Yeah, I think Deer on GUI would be really good because once I actually do want to make my own game engine someday, which I think is a good goal for any programmer, especially C++ developer, I think that's a good option because it seems pretty lightweight and a lot of people have recommended it. It's very nice and easy to use because it's intermediate mode rather than retained mode. Gotcha. Hey, how's it going, Kyle? I hope I said that right. I'm really bad with names. Welcome to the stream. We're learning OpenGL right now, which is awesome, of course. Also, I just realized my Pomodoro is not on the screen. So let me move stuff around. Right now we're learning a little bit about how to move the camera around in OpenGL, which is great. Yes, that's right. Awesome. I'm happy to hear that. Okay, so I can move this back here. Hopefully you guys can still see that. Okay. I feel like even though I'm really tired, like I'm learning this chapter a lot faster than last time. So I know how that works. Movement speed. Now we want to use a delta time so that it keeps... Basically, it makes it so that it keeps track of the frame rather than a constant velocity or like speed. Our delta time basically checks the time between the frames rather than something that it could be very inconsistent on different hardware, which is good. Future father. How's it going? Oh, it's going good. I'm a father now, actually. I'm not a future father. Let's see. Even the setup part for OpenGL is intimidating to me. Honestly, like, that's so fair. I think the first couple chapters, I was like, what the heck am I doing? Like, why am I... What are all these vectors and math? Like, what does all this math have to do with graphics programming? But honestly, like, if you write stuff down by hand or like take it one thing at a time, like I think note taking is really important for this kind of stuff because you want to like get good at like understanding the parts of the system. The setup is just the start, and I think once you get a setup working, it's like, oh, okay, first you got to make, you got to initialize GLFW and GLAD, and then you got to make the window hints so that it works on your system, and then you initialize a window and window height and all that, and then you can create a loop or a render loop. So yeah, congratulations, thank you. How long have you been learning OpenGL? So I was learning, this is technically my second week. Well, actually, it's probably more like 15 or 16 days. I'm counting it by days and not by like the day of, because I've had a big break because my baby was born, and so I took about a week off before I jumped back into it. This is my first stream back. Yeah, I mean, this is what I've gotten done in about 2 weeks. But I'm also kind of a slow learner when it comes to certain stuff because I like to understand everything pretty well. I mean, we got a bunch of cubes rendered that rotate or they're static as well. Which obviously, if we go up to our current texture and we just change this to 0, this will be the Minecraft texture block, which is fun here. Yeah, which I need to actually change where we're starting. So if we go to our view matrix or our look at, were you good at C++ before moving towards OpenGL? How would you rate yourself at C++ out of 10? I think I'm with C++, I'm probably like a 4. And that's not because I'm not necessarily good at it. It's more of like, there's so much to C++ that I haven't really like applied all of that learning into different projects. Like I have. I mean, I'm pretty good with object-oriented stuff and like that kind of workflow and like objects and classes. But I wouldn't say that like I'm great at using C++'s newest features. So like if someone asked me like what are the newest features in C++ 20, that's something I don't quite understand yet because I'm still learning through Learn CPP. But yeah, I would say I'm like a 4. Like I think I would be good enough to like get a job, like an entry-level job. But I don't think I would be. I can't call myself like an expert. That's for sure. Like I still have a long way to go. I'm like a little bit under average when it comes to the C++ standards and stuff. Like I would say I'm pretty decent. Like if someone asked me, how am I learning OpenGL and C++? So I've been doing C++ for like over a year now, and I'm learning it slowly. So like I did it through school and like just through random projects. I didn't learn the language itself super well in classes. I learned mainly how to like make the projects themselves. It was more of like, how do you set up an encapsulated project? How do you like, what's modularization? What are all these different metrics that you need to make and keep track of? And C++ just came naturally as I was going along, and I definitely like struggled a bit because there's a lot of different stuff. So like, let me pull up one of my projects, and I'll show you. Have I done any degree? Yeah, I'm actually graduating with my bachelor's in. I'm graduating with my bachelor's in software engineering in 2 weeks. So that's been good. Let me pull up one sec. I'll pull up another C++ project that was pretty advanced. Which university, if shareable? I probably won't share that just because, I don't know, I just don't feel like sharing that online. If it was like a big university like Harvard, I would share it, but I mean, yeah. I'm in the US. That's what I will share for sure. So here's like an example. Let me try and open this. Here we go. So let's see. I'm like pretty like, if someone was to ask me like, what is all this stuff doing? I would say, yeah, I would know for the most part. But like, if we look into all of our classes themselves, like there's a lot that goes into physics. Like this was a orbital simulator in C++. This uses OpenGL as well, but basically all the graphics part were set up for us in a UI draw, which like my professor just provided all of these methods for us. Yeah, this uses Glut or Glut. I don't know how you say it, but it's OpenGL basically. And then he like drew each shape. But I mean, yeah, like learning this stuff was really good. Learning about acceleration, learning about velocity, all that type of stuff. Can I share that code? I'm also in the US. I think I'm a freshman at your uni. What university are you at? I mean, I probably won't share that. You don't have to share it either, but let's see, can you share that code? I probably won't share. This was like a class project and my teacher probably doesn't, I know my professor doesn't want like coursework being released everywhere, so I probably can't share that. But I mean, if I was going to do something similar, of course I'd share that, yeah. Okay, so, let's see. Yeah, so I'm about to get my bachelor's in software engineering in about 2 weeks. And I've had a few internships already, mainly in project management and one in software engineering. And I'm gonna try and get into more embedded systems or graphics programming, but there's not a lot of graphics programming jobs. There might be more game development jobs. So that's why I'm like probably just gonna go stick to back-end stuff. We'll see where I end up. I don't know yet. Wherever I can get in, it would be good to get experience, obviously. Alright, so now we need to make a delta time. And we can just make these global variables. Float delta time. Yeah, I'm a senior right now in my undergraduate. I probably won't be getting my master's at least for a while. I've thought about it, but I like want to make sure that I get a good, I want to like get in some experience before I do anything like that. Like some more professional experience. Within each frame, we then calculate a new delta time value for later use. So then down in our render loop within each frame, how would you recommend someone who's about to learn C++ and OpenGL? Or, okay, I would first say if you're starting programming and C++ is your first language, then definitely like reconsider what you're doing. I would say that that's not the best choice, because I would say C would be the best choice because it forces you to learn more about objects from a different perspective. Like C++ hands you objects and classes and a bunch of other stuff that handles memory allocation, but C, you would learn a lot more generic principles that are transferable to C++ and other topics, which is great. So I'd say learn C if you haven't learned C++. If you're learning C++, start with learncpp.com and definitely like look into like just start with small projects, I guess, is my suggestion. Like I would say, let's see, let me pull this up. I just made like a CGPA calculator. I mean, you can see here it's got like six class files, and then our main like our main as well. And then we just have a make file basically that builds it for us. It looks for all of our CPP files, compiles it, and links them. And then we have down here like a simple GPA calculator. So like it says there's no student found. That's fine. We can go to our student menu. We can look up a student. We can, I mean, just stuff that like teaches you how to write functions properly, how to use classes and objects, how to use pointers and memory allocations is really great. I think that OpenGL is really great because it abstracts a lot of the really hard stuff, like the memory management parts, certain parts of it. There's definitely like, you need to be careful about deleting your shaders and textures and stuff from the buffers. But yeah, I would just say do learn CPP, like do at least like half of it, and then go to learn OpenGL if you really want to learn it fast. But I did about half of learn CPP, and then I was like, I feel like I know enough to start OpenGL. So, and then I obviously want to make games eventually. So yeah, we have our movement speed, and then basically we need to calculate this. So we need to set our current frame equal to our get time. And then we would do delta time. Also, join the Discord, guys. It's in the description. I'll actually put this in the... I'm going to put this in the chat. If you guys want to join, I'm happy to talk to you guys more and answer your questions. And we got about 30 people in the server now, and a lot of people that know what they're doing when it comes to this stuff. So yeah, feel free to join and ask questions if you... There's a discussion forum that you can post in. Last frame is equal to current frame. So we basically update our delta time, which is our current frame, minus the last frame, and then we then set our last frame equal to the current frame again. And now that we have delta time, we can take it into account when calculating the velocities. So now we can go into our camera speed and then set this to 2.5f times the delta time. And now our camera speed is definitely more consistent, and we can even do something like 10. Yeah, you can see here that's way faster, which I need to back up. So we need to look at our view matrix. Our camera position. Let's see. We're starting like right at the origin, so I need to fix this. I'll probably be done streaming soonish. just because I am busy. But let's see. Our projection matrix. We need to see where our view is. Okay, that should be fine. View location. This is what we're pointing at, so this shouldn't. Yeah, that's not gonna do it. That's any good. It's I think it's our. Maybe our look at matrix. Camera position. Oh wait, that's why. Our camera position should be at 3, positive 3, and it's at 0. I was like, what the heck? Why isn't this working? There we go. I was like stuck on that for a sec. Okay, now that we're all caught up on camera speed / delta time and camera movement. And basically what we want to do next is look around, but I think I'm going to stop there just because I've been streaming for a little over an hour and I got to go do some stuff. But I appreciate you guys being here. I'm going to come back probably either tomorrow or in a few days and we'll do some more. But yeah, if you guys have questions, join the Discord. Feel free to like the stream. I just appreciate you guys all being here. And yeah, have a wonderful rest of your day. I will talk to you guys in the next stream and in the Discord if you're there. So see you guys.